Snoopy takes his place as the weather forecast is 70% go for the Artemis launch. The Webb telescope detects carbon dioxide in an exoplanet atmosphere, and our Cubesat preview looks at the Argo Moon mission. This and more on today's WSN Space Newscast.
Three, two, 1, 0.
Now, here is World Spaceflight News Editor, Randall Schutler.
Greetings! Here are today's top stories. Preparations continue for the Monday Artemis 1 launch attempt. Meteorologists with the Space Launch Delta 45 Weather Squadron are predicting a 30% chance of no-go weather. Although unsettled weather with showers and thunderstorms will predominate in the next few days on the Space Coast, a southeast flow should lower storm chances on Sunday into Monday. This onshore flow will create some scattered showers through the launch window. The primary weather concerns are cumulus clouds, flight through precipitation, and surface electric fields. Upper-level winds and solar activity are forecast to be low risk. Temperature will be in the low 80s with a miserable 90% humidity. Reporter Eric Berger, who has experience covering the weather as well as space, tweets that he's less confident about the weather for the second launch attempt day, Friday, September 2nd. Meanwhile, at the pad, the zero-gravity indicator, Snoopy, has been placed inside the Orion crew module. Jason Hutt, NASA manager for the Orion Systems Engineering and Integration, also reports that the hatch has been closed for the final time before launch. Astronauts and astronaut candidates took their T-38 jets to KSC for a spectacular flyover of the launch pad. NASA's Ames Research Center has released videos showing supercomputer simulations of the launch plume from the SLS rocket at ignition. 4 RS-25 Hydrolox engines and 2 solid rocket motors, each with 5 segments, will pummel the launch pad. The core stage engines will ignite 6.36 seconds prior to SRM ignition. Standing 177 feet tall, the SLS booster is the largest, most powerful solid propellant booster ever built for flight, with more than 3 million pounds of thrust generated by each rocket. The SLS core stage is the tallest and most powerful rocket stage NASA has ever built. It measures approximately 212 feet tall and 27.6 feet in diameter. The stage is the largest ever built by length and volume, and its fully fueled weight, excluding engines, is 2.4 million pounds. The core stage is made up of 10 major barrel sections, 4 dome sections, and 7 rings. Each cylindrical barrel section consists of 8 aluminum panels that vary in length and height dependent on the section. Those panels are friction stir-welded or bolted vertically and horizontally to form the 5 major sections of the core stage: engine section, liquid hydrogen tank, inner tank, liquid oxygen tank, and forward skirt. Friction stir welding transforms the metals from a solid state into a plastic-like state, and then mechanically stirs the materials together under pressure to form a welded joint, producing high-strength bonds virtually free of defects. The inner tank is the lone bolted section. It provides added strength to carry booster loads. Elsewhere at the Cape, SpaceX conducted a static fire of its Falcon 9 rocket in preparation for another Starlink launch, now scheduled for Saturday evening at 10:22 p.m. Eastern Time from Space Launch Complex 40. It will be the 38th SpaceX launch of the year, continuing the unprecedented launch cadence, and the 57th Starlink flight with another 53 satellites. It's the last planned launch from the Cape before the SLS launch attempt. When considering the investment in the Starlink constellation, there are estimates that each Falcon 9 launch costs up to $30 million. Thus, the total cost of launches alone for the Starlink mega constellation may be on the order of $1.5 billion or more thus far. Launch of the SWOT Earth Science Satellite, SWOT, from Vandenberg Space Force Base has been moved to December 5th to accommodate transportation of the craft from France. The Surface, Water, and Ocean Topography mission will fly aboard a Falcon 9 rocket. It is the first satellite mission to survey nearly all water on our planet, viewing our liquid asset in higher definition than ever before. More SpaceX news. The launch of Crew 5 to the International Space Station is now set for Monday, October 3rd, delayed from late September, in order to deal with traffic at the station. Dragon Endurance will carry 2 NASA astronauts, Nicole Mann and Josh Casada, along with JAXA astronaut Koichi Wakata and Russian Anna Kakina. One of the first transformative early science results from our just wonderful Webb Space Telescope, the first unambiguous detection of carbon dioxide in the atmosphere of an exoplanet. This observation of a gas giant planet orbiting a sun-like star 700 light-years away provides important insights into the composition and formation of the planet. The finding, accepted for publication in Nature, offers evidence that in the future Webb may be able to detect and measure carbon dioxide in the thinner atmospheres of smaller rocky planets. WASP-39b is a hot gas giant with a mass roughly 1/4 that of Jupiter, about the same as Saturn, and a diameter 1.3 times greater than Jupiter. Its extreme puffiness is related in part to its high temperature, about 1600 degrees Fahrenheit. Unlike the cooler, more compact gas giants in our solar system, WASP-39b orbits very close to its star, about 1/8 the distance between the Sun and Mercury, completing one circuit in just over 4 Earth days. The planet's discovery, reported in 2011, was made based on ground-based detections of the subtle periodic dimming of light from its host star as the planet transits in front of the star. Previous observations from other telescopes, including NASA's Hubble and Spitzer, revealed the presence of water vapor, sodium, and potassium in the planet's atmosphere. Webb's unmatched infrared sensitivity has now confirmed the presence of carbon dioxide as well. The research team used Webb's near-infrared spectrograph, NIRSpec, for its observations. In the resulting spectrum of the exoplanet's atmosphere, a small hill between 4.1 and 4.6 microns presents the first clear, detailed evidence for carbon dioxide ever detected in a planet outside the solar system. No observatory has ever measured such subtle differences in brightness of so many individual colors across the 3 to 5 micron range in an exoplanet transmission spectrum before. Access to this part of the spectrum is crucial for measuring abundances of gases like water and methane, as well as carbon dioxide, which are thought to exist in many different types of exoplanets. Quote, detecting such a clear signal of carbon dioxide on WASP-39b bodes well for the detection of atmospheres on smaller terrestrial-sized planets, said Natalie Batalla of the University of California at Santa Cruz, who leads the team. Understanding the composition of a planet's atmosphere is important because it tells us something about the origin of the planet and how it evolved. Carbon dioxide molecules are sensitive tracers of the story of planet formation, said Mike Line of Arizona State University. By measuring this carbon dioxide, we can determine how much solid versus how much gaseous material was used to form the gas giant planet. In the coming decade, JWST will make this measurement for a variety of planets, providing insight into the details of how planets form and the uniqueness of our own solar system. ESA Senior Science Advisor and JST scientist Mark McCaughrean, tweets, "This discovery, derived from a single transit with a brand new telescope and instrument that were only commissioned less than 2 months ago, show just how revolutionary it is going to be in this field. Transit survey telescopes like Kepler, WASP, and TESS have discovered many exciting exoplanets, from gas and ice giants to rocky worlds, which Webb will be able to measure the atmospheres of. Some will be in the habitable zone of their stars, like some of the TRAPPIST planets. Further detailed characterization of the telescope and instruments, plus the addition of data from multiple transits, promises much more sensitivity to a range of molecules, which will help us understand the properties of those planets and perhaps whether some could even host life. To be clear, it's unlikely that JWST will be able to detect unambiguous signs of life itself, at least as we know it. But it will provide us with many great places where at least the atmospheric conditions could be suitable to host life, to be studied with future missions." Today we welcome to our team cyberspace correspondent Karen Calvis. You'll hear her in video voiceovers throughout our broadcasts. We continue our previews of the Cubesats that will launch on Artemis 1. Today it's Argo Moon. If it works, it should transmit high-def images of the ICPS upper stage, the Earth, and the Moon. It was among the 5 Cubesats to have its battery recharged while awaiting launch. Here's our video description.
Argo Moon, developed by Italian company Argotec and sponsored by Agenzia Spaziale Italiana ASI, Italy's national space agency, will perform autonomous visual-based proximity operations around the Interim Cryogenic Propulsion Stage, ICPS, the upper stage of the SLS rocket that provides the propulsion to send Orion on a lunar trajectory. The CubeSat will use high-definition cameras and advanced imaging software to record images of the ICPS and later of the Earth and the Moon for historical documentation, provide mission data on the deployment of other CubeSats, and test optical communication capabilities between the CubeSat and Earth. Argo Moon will use a hybrid micropropulsion system, MIPS, that combines green monopropellant and cold gas propulsion in a single system to provide attitude control and orbital maneuvering using a small amount of power. The enhanced attitude capabilities are also used to run and validate artificial intelligence-based algorithms for autonomous failure detection, isolation, and recovery systems that perform continuous monitoring of the health of the satellite to detect any potential fault. In the case of fault detection, this service performs several operations to solve the problem. If the fault is not recoverable, the satellite goes in safe mode, which means that only the functionalities to keep the satellite alive and to communicate with ground are used. Argo Moon's mission is a forerunner of technologies for deep space application that can be used for inspection of satellites not originally designed to be serviced, without the involvement of the ground segment.
Tackling internet myths. Did the noise from Saturn V launches really melt concrete? There are claims floating around the internet that the incredibly loud noise from Saturn V launches melted concrete and started grass fires a mile away, but new findings say those ideas are undeniably false. Researchers from Brigham Young University used a physics-based model to estimate the acoustic levels of the Saturn V. They obtained a value of 203 decibels, which matched the very limited data from the 1960s. To put that number into perspective, commercial jet engines range from around 120 to 160 decibels. Since decibels are logarithmic, 200 would be about 10,000 engines. While the Saturn V was extremely loud, this kind of power is nowhere near enough to melt concrete or start fires. If reports about these phenomena are true, they likely stem from radiative heating via the plume or debris. Now these researchers have used their framework to predict SLS's sound levels, and they plan to make acoustical measurements at its launch to help further refine predictions. And now in additional astronomical news, observations from NASA's TESS exoplanet survey telescope have led to the discovery of TOI 1452b, orbiting one of two small stars in a binary system located in the Draco constellation only 100 light-years from Earth. This discovery was made by astronomers at the University of Montreal. The exoplanet is 70% larger than Earth and is located at a distance from its star where its temperature would be neither too hot nor too cold for liquid water to exist on its surface. It could be an ocean planet, completely covered by a thick layer of water, similar to some of Jupiter's and Saturn's moons. Its apparent density makes it a prime candidate for a true ocean planet with far more water than Earth. Water may constitute as much as 30% of its mass, like Ganymede, Callisto, Titan, and Enceladus. Today we're introducing our daily update on space business and stock market activity. We've compiled a watch list of 28 companies and funds in the space arena using barchart.com. In addition, we will present charts from the New Space Index, produced by the company SpaceWorks out of Atlanta, Georgia. The SpaceWorks NSI tracks the relative performance of publicly traded space companies to the S&P 500 and Dow Jones Industrial Average. We would like to thank Hayden McGill, economic analyst and primary developer of the index, for granting permission to reproduce their interesting work here.
Our stock market coverage begins with charts of the 28 selected aerospace companies on our barchart.com watch list. The vast majority rose today, in concert with the market rebound from the last few down days. Virgin Orbit was unchanged, and 3 took a hit: Tesla, Ball, and AST SpaceMobile. We include Tesla because of the importance of the company to Musk and his financial standing. AST stands out as the biggest loser. The company is working on a space-based cellular network that would link to conventional smartphones. We could find no specific news on the company today, but it was probably impacted by the pending announcement of a partnership between Starlink and T-Mobile. The SpaceWorks New Space Index is a unique tool. According to the company, it provides insight into how publicly traded companies within the space industry are performing relative to those within the S&P 500 and the Dow Jones Industrial Average. Today we show the full index since 2021, by company, and charts for the past 10 and 30 days.
And that's the way space is today. Until tomorrow, ad in explorata, toward the unknown in the measureless arena of space. Stay tough and competent. Thanks for watching.